We are live. Hi everyone, welcome back to Geeks for Geeks Practice. Today in this video we'll be discussing the Geeks for Geeks daily problem of the day for 31st of January. The name of the problem is cousins of a given node. This particular problem previously has been asked in some of the organizations as well, like it has been asked previously in Microsoft. Maybe similar question might have been asked in Amazon as well. So consider giving me a +1 in the chat if my voice is audible to everyone and my screen is visible, and then we'll start with this particular problem. Also let me know how many of you have solved this particular problem and what was your approach while solving this problem, right? So this is the problem of the day that we'll be discussing today. It's based on trees, but before starting you can just give me a +1 in the chat. And also there's one initiative that is by Geeks for Geeks. So there's a channel that is we have Code Era, which is powered by Geeks for Geeks. So you can consider to subscribe this channel if you are someone who is wanting to do lead code daily challenges and who wants code forces at coder and lead code coding contest editorial. So you can consider to subscribe this channel. Now coming back to this particular question, consider giving me a quick +1 in the chat and like the video as well, so that we can start with this particular problem, right? Also let me know how many of you have solved this problem and what was your approach while solving this problem, if you have solved it, right? If you haven't solved it, so don't worry, we'll solve it, and then after the session is over you will definitely submit the code by yourself, right? So this particular problem, as I said, like you will be given a particular binary tree and you'll be given a node for that particular binary tree, and you have to print all the cousins of the given node in order of their appearance, right? So you have to print them, I guess, in left to right order. So note that the sibling should not be printed, right? So what does it mean? So if you have been given like a tree like 1 2 3 4 5 6 and 7, if you have been given this particular tree, then in that case, if the node that has been given to you is, let's say, 5, if 5 is the node that has been given to you, so you have to print all the siblings of 5, right? Let me just use my pen to explain it a little bit better. So if you have, let's say, 1 is connected to 2 is connected to 3, then this way, 4 5, and you have 6 and you have 7, right? So if you have been given a node, let's say 5, if you have been given the node 5 and you have to find all the cousins for that particular node, right? So who will be the cousins of the node 5? Can someone tell me in the chat? Give me a +1 in the chat if the question up till now is clear to all of you. You have to find the cousins and give me a +1 in the chat and let me know what do you think, what is a cousin, right? So if you are saying about this particular node, so for this particular node, this is the parent, like 2 is the parent node, right? I know that 2 is the parent node for this particular child, right? If 2 is a parent, then this means 4 is the sibling, right? 4 is the sibling. And if 1 is the grandparent, then what is 3? 3 is the uncle, right? 3 is the uncle of 5. So that means 6 and 7 are cousins, right? The nodes 6 and 7 are cousins. Please give me a +1 in the chat if this part is clear to everyone, right? What are basically cousins, right? Cousins are the nodes which are on the same level but they belong to a different parent, right? Cousins here mean nothing but the nodes that are on the same level, right? That are on the same level, because if they are cousins, so they will be your counterparts, right? They will be of the same age, so that means they will be on the same level. So cousins are nodes which are on the same level but they belong to a different parent and not the same parent. If a node is belonging to the same parent, then the node, he or she node, would be a sibling and not a cousin, right? So is this part clear to everyone? The 6 and 7 are cousins, right? And since 6 and 7 are occurring from the left to right order, so you'll maintain this order and you'll be returning this in a vector, right? Give me a +1 in the chat if this much part of the question is clear to everyone, right? And then I'll begin with this question. Like if I say that, let's say I have a tree like this. If let's say I have something like this, that is 1 is connected to 2 is connected to 3, right? If I have something like this, then if I have a node 2, then for this node 2, what is the cousin? So 3 is the cousin, right? No, 3 is not the cousin, right? 3 is the sibling, right? 3 is the sibling. So 3 is not the cousin. Why? Because 3 is the sibling. 3 is belonging to the same parent 1. 1 is the parent of 2 and 3 is also the parent of 2, right? So that is why for this particular case you will not have any cousin. So you'll return a -1 for this case, right? Let me show you some more cases if we have to discuss. Like let's say if we have a structure like this, 1 is connected to 2 and then 3, this 4 5, let's say 6 7, let's say this is 8 9, just make a better 11, and then let me just decrease this size, right, so that we can understand it better, right? If let's say if you have this particular node, right, if you have this particular node, if you have been given node 6, right, So what is the parent? Parent is 3. Parent is nothing but 3, right? So that means 7 will be the sibling, right? 7 is the sibling. So that means what are the cousin nodes? Cousin nodes are the ones which are present on the same level, but they belong to a different parent, right? So that means this particular node, right? Because the grandparent is 1. So since 1 is the parent of 3, so 1 is also the parent of 2. That means the 4 and 5 are belonging as cousins, right? Is this much part clear to everyone, right? 7 is the sibling and 4 and 5 are cousins. For the node 6, for the node with value 6, 4 and 5 are the cousins because they are belonging on the same level and they belong to a different level. 7 is a sibling, right? If this much part is clear, so please consider giving me a +1 and please like the video, right? So this much part I hope is clear, right? Now let's talk about the second, another test case as well for this particular problem. So let me look at the second test case for this problem. Like if you have suppose been given 9 and 5, right? If you have been given something like this, if you have been given, as I said, 9 and 5, so if you have been given the node 5, then for this particular node it even does not have a sibling, right? So does this 5 have a cousin? No, its parent is 9, so it is not having any cousin, right? Since it is not having any cousin, so that's why what you will do, you will simply say that since it's not having any cousin, so that's why you will return a -1 in a vector, right? Okay, now I have told you this particular problem. So shall I begin with the approach? So now you must be very much clear that if you want to find all the nodes which are on the same level, right? Because what are cousins? As I told you, like this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Let's say we were considering for the node 6, right? For the node 6, what are its cousins? So cousin, as we discussed, would be on the same level. So 4 is a cousin, 5 is a cousin, right? These two are cousins. They belong on the same level, right? They are on the same level, but they belong to a different parent, right? And you'll be storing these into a vector and you'll be returning them, right? This is the part that you have to implement in this particular question, and this question was asked in Microsoft. Now let me discuss like how we can approach this particular problem. So now one thing is clear to us, that we can approach this problem better when we are applying a level order traversal, right? A level order traversal or a BFS, you can say, is very much intuitive for this particular problem. What is the reason why BFS is intuitive for us? Because we want to find all the nodes that are on the same level but they belong to a different parent, right? All the nodes that are on the same level, but why I'm repeating this, because this is the part that you need to consider. Rest everything implementation is very much simple, that I'll be showing you like how we'll be developing the code for it. If I have the node 6, right, so all the nodes that are on the same level I'll be getting access to all the nodes that are same level through a BFS, right? And I need to store all the nodes which are on the same level but they belong to a different parent compared to 6 parent, right? That is the parent 3. Every other node which is on the same level but is having a different parent, right? So that will be my cousin. So how will I approach this particular part? That's the challenge that lies ahead of me, right? So what I would be doing is I can say that I'll be applying a BFS, right? This much part is pretty much intuitive, that since I have to apply BFS. Why I have to apply a BFS? Because I have to consider the nodes which are on the level order, right? I have to do level order traversal for this particular part, right? So what I would be doing is like I would be declaring a queue, right? You can give me a +1 in the chart if up till now things are clear to you, and also if someone new has joined, so you can give me a like to the video, right? So you have a node like node star queue, right? In the queue, what you will do, you will push first of all the root, right? First of all you will push the root. So queue dot push, first of all you push the root, right? First of all you are pushing the root. Okay, once you have pushed the root, so what happens next? Once you have pushed the root, so everyone knows that you will be considering what you will, in the end you have to consider all the nodes that are on the same level. So that means that you have to apply a breadth first search first of all, right? So you will be doing what? You will be writing while not of queue dot empty. So until and unless my queue is empty, I'll be running it, right? So until and unless my queue is empty, I'll be running it. So let me just make some space for this so that we can also dry run my code. Okay, so this is something that we are planning to do. Give me a second, right? Okay, so what I'm saying is, if you have 1 is connected to 2, 2 is connected to 3, 3 is connected to 4, 4 is connected to 5, 5 is connected to 6, and then sorry, I'm saying it in the wrong way, but you can understand, right? So this is the thing. If this is the thing, and if I have been given, let's say if I was given, right, let's say node 5 only, right? If I was given node 5, then I have to first of all reach these nodes, right? How many nodes are there on this particular level? Can I say that there is only one node in this particular level? How many nodes are there on this level? 2 nodes are there on this level. How many nodes nodes are on this level? 4 nodes are there on this level, right? So how do I check that, right? How do I check that? So what I would be doing is, initially before starting, I would say that int sz, I'll calculate what is the size of the current level, right? I'll calculate first of all that what is the size of the current level. So I'll say that int size is equal to nothing but q dot size, right? So whatever is the all the nodes are there, I'll be having them. Then I'll be running for this particular level, right? So I'll do while size minus minus. So I'll be iterating through this particular level, right? I'll be explaining you a little bit more through the diagram, but first let's try to build the code. So what I'll be doing is, what is my current node? Current node is nothing but q dot front, right? Current node of the tree would be nothing but q dot front, right? I'll pop this out. I'll say that let's q dot pop, right? Let's pop this node out. Now what is the thing that lies ahead of me? What is the thing that lies ahead of me? I'll simply check, right? Let's say if I was at 2, right? Let's say if I pushed 1, first of all I pushed 1, right? So the size was 1, so it was waiting till 1, then this loop got over. So from 1 I pushed 2 and 3, right? So once I pushed 2 and 3, so what happened next? My size became 2, right? My size became 2. This particular node got eroded away, right? Hi Shreya, right? So this particular node got popped out. Then I had 2 and 3, so the size was this, and these were the 2 nodes that were present. Now notice one thing: if my node that I want to find, if I want to find all the cousins of the node 5, right? If I want to find all the cousins of this node 5, right? So what can I observe? What can I observe for this particular thing? Can I say that if I check for 2's left, right? If I'm checking for 2, if the left child of 2, if for a particular node, if its left child or the right child is the node that I want, is the node that for which I want the cousins to be found, right? If this is the current node, right? If this is the node, if 2 is the node for which, it is having child 4 and 5, and for 5 is the node for which I want to find its cousins. That means all the siblings of 5 will not be in my answer, right? So I'll not be pushing them into my answer. I don't need to push 4 into my answer as well, right? I don't need to push 4 into my queue. Why? Because if there is a parent, right? If there is a node such that its left or the right child, if there is a current, let's suppose my current is 2, okay? What I'm saying is, let us suppose that if my current is 2, then if my current's left or my current's right node is the node for which I am looking for the cousin, right? So that means for that particular node, if its left or the right child is the node for which I am looking for the cousin, like in this case it is 5. So for 2's right child is 5, and I know that for 5 I am looking for its sibling. I am looking for its cousins, right? So that means I do not need its sibling. So that means if 2 is having a child is 5, then I will not. If 2 is having a child is 5, then I know that I'll not push 4 into my answer, right? I'll not push 4 into my answer. Why I'll not push 4 into my answer? Because 4 is the sibling, right? So this is what I'm saying. Let's suppose that if you were here only, right? Assume that the node that you wanted to for which you wanted to find the cousin was 6, right? If let's say the node was 4, right? Let's say the node was 4. Okay, so if my current was 2, so that means current left was what I wanted to find all the cousins of the node 4. So will 5 be counted in my answer? Will 5 be also be included in my answer? No, 5 will not be included in my answer, right? What's the reason for that? 5 will not be included in my answer. The simple reason is because it is the sibling, right? Because it is belonging to the same parent. So if I will check if I am at the current node, and if I am at the current node, what is the current node? Current node is currently, you can say 2. So if I am at the current node and its left child or its right child, okay, if its left child or its right child are the ones for which I want to find the cousins, so that means I'll not be pushing the children of current because they will be siblings, right? So I will not push them. Please give me a +1 in the chat if this much part is clear to everyone, right? So I'll not push them. So this is what I would do. Now next up, what will happen? Like in my queue, I will have next up, I'll have 3, right? So I have 3. So for 3, what I'll do, I'll push 6 and 7, right? So I'll push 6 and 7, and 6 and 7 would be there in my queue, and I know that 6 and 7 are my answer. So once I have traversed for this particular level, then it does not matter whether the tree is existing down or not, right? Because if I wanted to find for this particular, if I found that at this particular level there is a node existing for which I want to find its cousin, so all of them would be at the same level, right? because we are doing a level order traversal. So that's why 6 and 7 would be my answers, right? So I'll get them, and once I get them, so I'll simply break, right? Is this much part clear to everyone? Let me show you the code, like how actually I'm implementing it, so that you can get a little bit better grasp of it, right? So let me show you, right, how what we'll be doing. What I will be doing is, I'll be first of all declaring a queue, then I'll be having a root, right? I'll mark my int flag as 1. That I'll explain you, don't worry about the flag currently. The flag means that when we have reached that level, when we have reached that level at which our node for which we want to find the cousins is existing, right? So what I would be doing is, I am saying that while node of queue.empty, right? So this is the standard BFS template, right? So you calculate the size of the current levels, right? This is nothing but size of current level, right? This is nothing but size of current level, right? Current level of tree, right? Current tree level. Like I am iterating for all the nodes that are present on this particular level. So I find my current, okay, I'll find my current. So current is equal to nothing but q.front. I pop it out, and what I'm saying is, if the left child, if for the current node, if the left child is equal to the node for which I am finding its sibling, right? This node to find will be given to me. This node to find would be given to me. If for the left node, if for the current's left node or for the current's right node, if that is the node for which I am trying to find the sibling, the cousins. So if this is the node, if current's left or right is the node for which I want to find its sibling, so that means that for that particular node I'll be not pushing them into my queue, right? I'll not push them into my queue. What's the reason why I'll not push them into the queue? Because if the node that I want to find, if that is the node for which I want to find my cousin, so I will not be pushing them into my queue, right? Because they either it will be the node that for which I want to find the cousin, or it will be the node which is the sibling, right? So that's why I'll not push it, and I'll mark my flag as 0, indicating that I have reached that level. This size, this loop, this while size minus loop would help me to do what? Would help me to traverse all the nodes that are present in that particular level, right? Because all of them would be stored beforehand in my queue, right? So what I'm saying is, if the current node that I am at, if it is having a left child or a right child size that is equal to the node for which I want to find the cousin, so I'll skip that particular node for putting it into the queue, and what I'll do, I'll simply mark my flag as 0, indicating that I have reached this particular level, right? At which I want to have my cousins, right? For which I want to have my cousins. Otherwise, if the current node's left is existing, so I'll push it into the queue. If the current's node right is existing, so I'll push it into my queue. Like if my current is 3, if my current was 3, then for it I would push, like let me show you here, right? What I'm saying is this thing. Let me explain it. Okay, so this is the thing, right? What I'm saying is, if this is my node for which I wanted to find, like in my queue currently I would be having, let's say, 2 and 3, right? So if I'm at 2, so will I push 5, 4 or 5? No, I'll not push 4 or 5. Why? Because these are the nodes that for which I do not want my these are not my cousins, right? These are not my cousins, right? 4 is not my cousins, and 5 is the node for which I want to find, right? So what I will say is, if 5 is the node for which I want to find, so if the current is 2, so if its left or right child is the one for which I want to find the cousins for, so I'll skip this much part, right? I'll skip this whole subtree, right, for 2, right? So what I'll say is, if I'm at 3, so 2 will be popped out. Once I'm at 3, so I'm at 3, right? If I'm at 3, so that means that this particular level will be dealt with, that is 6 and 7, and since 6 and 7 would be my cousins for this particular level, so I'll simply push 6 and 7 into my queue, and 3 will get popped out. So in the end, 6 and 7 would be there present in my queue, so I just simply push 6 and 7 into my queue, and once I have done that, so since I have reached this particular level, so what would happen after this particular level is over, right? After the traversal for the current level, that is for the nodes 2 and 3 is over, so 6 and 7 is stored in my queue after this, right? So I'll say that I've seen this particular level for which I wanted to find the cousins, so I'll say that if my flag is 0, that means that I've reached that particular level at which I wanted to find my cousins, right? So that means that if my flag is 0, so I'll simply break from this particular loop, and what I would do is, I would declare a vector, right? If my queue dot size is greater than 0, that means if I have some nodes that are present in my queue still, so all those nodes are what? All those nodes are cousins node, right? All those nodes are cousins, right? All those nodes are cousins, nothing but cousin nodes. So I'll simply empty my queue, and I'll push all the current data into my queue, right? So I'll write while node of queue dot empty, so that if I am having let's say 6 and 7, so I'll be pushing them into my queue, right? And I'll be pushing like this. So v dot push back current data, and then I'll simply return the vector. Now if there is no node present in my queue after I've come out of the of my BFS traversal, so if there is no root currently present, so that would mean that there is no sibling. So that's why I'll simply push -1 and I'll return v. Please give me a +1 in the chat if this much part is clear to everyone, right? Is this much part clear to everyone? Please give me a +1 in the chat. Is this much part clear to everyone? Please give me a +1 in the chat if this part is clear. And since we are iterating through each node only once, so the time complexity would be order of n and the space complexity would be order of n as well. Let me submit this code for you and show you that it is getting accepted, right? Please give me a +1 in the chat if this much part is clear to everyone, right? Is it clear to you, Shreya, Aryan, Aman and others, right? So you can see that it got accepted. Like Rohit, it's clear to you as well, right? I'll explain it once again. What I was doing was I just pushed the current route. I mark my flag as 1, indicating that I have not reached the level at which my current node is lying, for which I want to find the sublinks for, right? So I'll have the size. So size will store what? Size will store nothing but the number of nodes that are at there for a particular level. So I'll be having a while loop for all that particular level, right? For all that particular level, I'll be having a while loop. I'll be taking out my current node and I'll be popping it out. If the current node is such that its left or its right child is the child for which I want to find its sibling, so that means for which I want to find its cousins, so that is why I'll mark my flag as 0, indicating that I have reached that particular level, and I will not push its children into my queue, because either it will be a sibling or it will be the node itself that I wanted to find for, right? So otherwise, if let's say I was at node 3, so if I was at node 3, so I'll push 6 and 7 for node 3, right? If its left is existing, so I'll push its left. If its right is existing as well, so I'll push its right. And if my flag is 0, so that means I have reached that particular level for which I wanted to find the cousins. And once I reach that particular level, so I'll simply break and I'll declare this is the ending of my BFS or my while loop of BFS. Once I'm done with that, so I'll declare a vector v. If my queue size is greater than 0, so that means I will be having some of the cousins present. So if some of the cousins are present, so I'll empty my queue one by one and I'll push them into the vector so that they get stored into my resultant vector, and I'll simply return my vector. If there is no sibling present, if there is no cousin present, right, so in that case I'll simply push back -1 and I'll return v, right? If this much part is clear, please give me a +1 in the chat and let me know, and like the video as well, right? Is this much part clear to everybody? I hope that it is clear to everyone. Please let me know in the chat. Is this much part clear to everyone? I hope that this particular problem was clear to everyone. This problem, as I said, was asked in organizations like Microsoft. So that's why you can consider to solve this particular problem. Now the problem of the day for today, that is 1st of February, is implementing Dijkstra's algorithm. So if you are someone who is new to this thing, so you can try to implement this particular question, because it has been asked in previously, it has been asked in Microsoft, and it has also been asked in Flipkart, right? So you can try to solve this particular problem, because you'll be getting a lot of good experience by solving this particular problem. And again, at the end, I would say that you can consider to subscribe our channel, that is Codera. If you haven't done that, you can share this with your friends as well. And if you like my explanations, you can let me know, like, what are the things that you like in the explanation. If there was something that you think that I could have improved, so you can also let me know about that as well. So this was it for today's problem of the day. Thanks a lot everyone for joining in. And if you have any questions, so I'm still here for let's say I'm here for 60 seconds. So if you want to say something or ask something, you can do that. Otherwise I'll end the stream, right? I hope that the problem was clear to everyone. So I can see Aryan is clear with the problem, Aman, Shreya, and everyone else is clear with this particular problem. So you can try to solve this particular problem, right? Also, like, if you want, so you can take a screenshot of this particular thing that I've implemented. Like, this is the first part, then this is the second part, right? So you could pause the video somewhere and you can take the screenshot, but I think that you will be able to implement it yourself. Is there anything that you want to say? Otherwise, I would end the stream, right? Okay, sure. So thanks a lot for watching. And again, I would say that if you are someone who is doing competitive programming or lead code problems, so you can consider to subscribe our new channel, which is powered by GeeksforGeeks, that is Codera. So you can consider to check out that channel. You can just search Codera and it would come. So thanks a lot for joining in, and I'll see you soon in the next live. Till then.